Hello, not sure if anyone's watching yet, but going live. Today's live stream probably won't be too interesting. I know in the last two, in the first one, we did some PCB inspection, and in the one after that, we unboxed the first batch of 3D printed components for the Printalizer densitometer. In this one, I'm probably going to give a little bit of a recap on where things stand with that, and then we'll probably go back to just doing some PCB inspection. Probably not going to be too long of a stream. I might only get through one panel on this one, but I've been making good progress overall. So, at the end of the last stream, um, I ran into a bit of a snag. Sort of the joke was, you see the good, the bad, and the ugly. Well, I had unboxed the first set of 3D printed components and discovered, to my great surprise, that the parts didn't fit. Well, over the weekend, I spent a lot of time going through pretty much every single part that I got, doing various tests on each one. So that's the main housing, the cover, the main bottom housing, and the bottom cover, inspecting all of them, checking some critical dimensions, surface texture, fit, everything. And the results were not that good. So I might have mentioned in the past that HP's multi-jet fusion 3D printing process can vary dramatically depending upon who's operating the machine and how much care they're putting in. And that the supplier that I'm going with, I picked specifically because they were on the good side of that spectrum, whereas a lot of the others I had previously tried were on the bad side. Well, this order, which they kind of had to outsource due to some extenuating circumstances, leaned more towards the bad side. So the percentage of parts that didn't meet my initial checks was a lot higher than it should have been. And given what these 3D printed parts cost, I'm not sure that I can really tolerate any throwaway parts, to be honest. It's just too expensive to have that kind of waste. So some subset of the parts did pass. The size of the subset depended on which part we're talking about and how nitpicky I want it to be with that particular part. For example, the top and bottom covers, I don't care as much about, in some internal dimension being off by half a millimeter. Some of the parts that have to fit mechanical components, it does matter there. And also whether I cared about surface texture, how much, whether I cared about die color, how much, it varied. But I've sort of gotten my initial full report of what I liked and what I didn't like off to my supplier, and I'm kind of giving that all a rest for this week. I probably have enough parts that I might be able to put together that initial production batch that I talked about, but I'm not really comfortable doing that yet until I know what the situation is. So hopefully within about a week or so, I'll know what the deal is. It's either going to be a partial replacement order or a complete one. Partial's more likely. And this wasn't everything I'd ordered in the first place anyways, so we'll see what happens. In any case, I think with sort of conveying my production plans before, one thing I wasn't really counting on was issues with the quality of 3D printed components and circuit boards and need to inspect them. What I've since discovered is I need to inspect all of both before I pretty much accept the order, before I can start building devices. So right now, the production plans are temporarily on hold, pending getting the 3D printed situation sorted out. How long of a delay that puts into my plans, I have no idea. Hopefully not much. The circuit boards, I've been going through and inspecting them. I've had to fix issues in far too many but at least the majority of issues are relatively easy to fix, and I'm not going to be throwing anything away. The number of boards that I'm going to have to fix later, once I'm kind of scraping the barrel and have most of the devices built, is relatively small, so that's good. So the majority of the boards do pass once I fix issues, even if the number of issues I have to fix is higher than I'd like. So my plan right now is to finish going through the entire circuit board order before I build a single device, just so I can get that cleared off out of the way and get my report back on that. So, not sure if anyone's listening right now, but yeah, so what we're going to be doing today is we're going to be inspecting the next panel in line. So, let me switch over to the computer and we'll get ready for our next panel. Okay, so the way we usually do this checkout is, first thing I do is I've got my panels here. We'll go to this checkout, add another 6 rows for the next panel. Okay, so this is going to be panel 26. Okay, we'll filter this. Okay, so here's how we're going to do this. So as you see in the other camera view, this is panel 26. So the first thing we're going to do is switch over to the workbench. Let me see if I can move the camera around. Okay. Let's see. Okay, so this process is pretty straightforward. I did this on my first stream. Take the board out. So this panel contains circuit boards 162 to 167. So we'll label the bag, move it out of the way. Now, one thing I've started doing since my first round of this is I now label everything here very well, so it's completely obvious what is, what board is what, and I'm not constantly second guessing myself. So this is panel 26. And the boards starting at the top would be 162. Okay, now we flip it over and label the boards themselves. So 162. one thing that I've done so far is I give the device and the circuit board the same serial number. For now, I think I'm going to stick with that because otherwise it'd be too hard to keep track of everything because the device doesn't have any serial number written on it until I print out a custom sticker. And if I tried to do them separately, they'd all be mismatched by one or two here and there, and it would just get weird. Okay, so the way this whole process works is the testing process consists of several steps. First, we have our visual inspection, where I go through and note anything that doesn't look right. Then we have a smoke test, where I power up each board and make sure that it's drawing the right amount of power from my power supply, and all of the power rails have the right voltage. Then we have the checkout test, where I actually load some firmware on it. At that point, we can test that the microcontroller is starting up. We can record the microcontroller serial number. We can test all the buttons, and we can see if all the LEDs are working correctly, and if it can read from the sensor correctly. And then once that checkout test is done, the last step is the USB test, where I plug it directly into this lab computer via USB and just make sure that it will show up as the bootloader device and the regular device. And throughout that, usually if there's anything that needs to be fixed, I'll do it right after the step where I spotted it. So there'll usually be some rework after the visual inspection and sometimes after the checkout step. I haven't had any issues after I've occasionally come up with an issue during that smoke test where I powered up, but it's almost always something I should have caught during the visual inspection. And the same goes for the USB test. So, that being said, I think it's about time to get started. Unfortunately, with this visual inspection, it's so much easier to know what's actually going on with this board. If I look, see, it's a stereo microscope, and if I really have to look with both eyes in order to see certain things. Like if a part's lifted off a pad slightly, that's much easier to see when I'm looking in stereo than with one eye. So if there's anything worth noting, I might switch over to the microscope camera to show you, but I'm unfortunately not going to have an easy way for you to follow along with this, because to turn the microscope camera on, I have to pretty much blind myself in one eye. So I'm going to start with 162. And I've got the computer over here. I'll just take note of anything that happens. I'm going to zoom out. Okay. Maybe when we get to the end of this, I'll switch over to the microscope camera a little bit just to show you what I'm looking at. Okay. Most common issues that I am mostly ignoring at this point are these little tiny diodes designed to shunt any static electric shocks to ground. In actual testing, it's almost impossible for someone to shock the device with their fingers, except through maybe the USB connector, which has a different kind of protection on it. So I'm not worrying too much about those. They're way too small and a little too easy to get messed up. I do note when I see something with them, but that's something too hard to really fix. So, okay. Yeah, I'm not quite as talkative with this. I need to just look very carefully. Okay, this first board Looks good. Now, it's always possible there's an LED soldering issue. I've come across a few too many of those, but those are much easier to spot on power up. Once I know there is one, you can sort of see it, but it's not very easy to see. So, gotta call this one no issues. Okay, next board. Now we might get lucky. I mean, I've had boards where almost everything is perfect, and I've had boards where there's a lot of issues. I run across both here. Hopefully the webcam is still picking up my voice pretty well. Looks like it is. That board's good. Yeah, having a stereo microscope really helps, because sometimes if a part is like lifted off on one pad, you can see that easily under stereo. If you were just looking without depth perception, it'd be a lot harder to notice. Okay, I'm impressed. No issues on that one. And even if everything's perfect, I wouldn't be the least bit surprised if we find the LED not lighting up. We've yet to have a panel with no issues. I really hope I start getting them. The most time-consuming parts of this entire process are the visual inspection and fixing any issues that I spot. Everything else, there's probably ways I could speed up what I'm doing, but I don't think it would make that big of a difference. So, just see something there I want to take a closer look at. Okay, there's a potential issue. And I could test it with a multimeter to be sure. See one component that might not be soldered perfectly. This falls under the category of I don't know if I need to fix it. Probably wouldn't hurt. Okay. So let's stick it up here. Continuity check is fine. This is one of those things that I might just fix and not fault anyone for. Let me pull up the microscope camera. Okay, so I got a slightly better lens thing on here. I don't know how easy it is to see. Let me prop this thing up at an angle. Sometimes that helps. Yeah, so this is not that easy to see, but let me see if I can point it out. So right here this part right here that's, well, the camera frame rate's really bad on the microscope. That's labeled FB1. On the right side of that, it doesn't look like it's making terrific contact with the pad. It still technically is making contact, but I think I'm going to fix that solder joint. Well, I'll make a note. In fact, actually, yeah, I'm going to label that as rework. So usually when I spot something like that, there's a bigger issue on the board, so I don't feel bad about including it. But we'll make that as a note to fix. I just don't want to take any chances, because if that connection flakes out, then power to the whole device will flake out. But everything else on this board looks good, so let's go to the next one. Still find it amazing that the areas I was most concerned about, that were most likely to have issues when I was hand building these boards, are completely different from what's, you know, not always perfect with the machine assembly. Not something I expected, but definitely a good learning experience. Okay. I feel like I need a microscope camera with a higher frame rate. That one's good. That one's okay for still pictures, but yeah, for video at least, something to be desired. Okay, except for that one joint, everything looks perfect. This is actually a first. I think with all these rework notes, I'm keeping track. If the assembler wants to dispute my numbers or wants a breakdown, I'll give an easy way providing that in case there's any sort of negotiation that ensues. So before I do any rework, I'm just going to bring the microscope camera up again. Maybe I can sort of give you a little look at what we're looking at on the board. So wonder if I can actually adjust the frame rate. Configure video option. Let's see. Let's see if we shut off auto exposure. No, I guess we're going to have to deal with this crappy frame rate. I'll get a better microscope camera eventually. Let's just zoom all the way out. So, it's probably not the best look, but yeah, so near the back we're looking at, you know, all the solder joints, all the connections, all the connectors. You know, are all these parts soldered correctly? Those little specs near the top, D5 through D10, I'm sort of looking at those. And of course over here, the light sensor. I've never found a sensor that was badly soldered. If you see R1 and C1, I've occasionally seen those badly soldered. But let me turn off the microscope and go ahead and fix that one joint before we start powering these things up. So that's board 151. Wait, no, sorry, 165. Yeah. Okay. have a little bit of flux. I'm gonna fix both sides of this one. Okay, this flux has been getting kind of gooey all over everything. This should be pretty easy. Lucky this will be a quick board. Flow it down to solder into that joint. And just for kicks, we'll do the other side too. Okay, that looks good. This is technically all no clean stuff, but just to be safe, I've been swishing these fixes around with a little bit of alcohol just to avoid goo on the boards. This is supposed to not leave any residue because it's the 99% stuff, not the stuff you find at the pharmacy, but it still sometimes seems to. I don't know if it's because the board's cleaner underneath it than the rest of it, or it's just that's what happens. So the next thing we're going to do is we're going to do what I call the smoke test. So the way the smoke test works is I have a benchtop power supply and a benchtop multimeter. And basically, I go around to each board and I plug it into power, and I look to see if its current draw, and let me make the webcam a little bigger. So, yeah, so on this meter right here, its current draw, when it's working correctly, the bottom one should show around 0.4 milliamps, give or take. If it's lower, something's disconnected. If it's higher, something's not connected correctly. If there's a short, it'll look weird. And then while that's on, I'll then use this and I'll just check to see that I'm getting 5 volts and 3.3 volts in the right places. There's really no good way for me to stick a camera here. I'm kind of holding it in the middle of thin air. So I'm just going to stick it back and have it look down at me. And the video camera will be on the board. And we're just going to go around one board at a time. And yeah, we'll just do the smoke test. And once the smoke test is done, we'll do the rest of them. If you hear any noise soon, that's just my wife opening the garage and heading out. Okay, so smoke testing. This should go pretty quick. We'll start with the first board. That's good. Oh yes. DC volts. Okay, I'm just gonna zip right through this. There'll be some background noise, just don't worry about it. Okay, so far so good. Originally I was doing some of the multimeter tests and the power up separately. I realized that was pointless because it's a current limited bench supply. If there's a dead short across the power rail, it will limit and it won't blow anything up. So that's actually okay. And so far I have only found a single board in this entire batch that had symptoms of a power rail short. I haven't figured out where they are. except the thermal camera told me what part to zone in on, and that's something I'll deal with later. Okay, smoke test is all good. One thing that you may notice is I have these cables, USB-C cables, I keep plugging and unplugging a zillion times. Well, I realize they do actually make special test connector USB things that have a lot less force with that might be a lot safer, and they're very expensive unless you part it out of something else. I did actually order one, but it won't be here anytime soon. So I just got to be careful when I pull them out. Okay, so now that our smoke test is done, the next step is the checkout test. In the checkout test, we're going to actually load firmware onto each board, make sure the buttons work, and make sure all the LEDs light up. So, for that, there'll be a bunch of stuff going on the screen. It might be easier if I switch over to the desktop. Yeah, okay. So, this window is where we're going to see output from the device once it gets its firmware loaded. And then I'm going to copy that over here. So this is where I keep track of the unique IDs of each microcontroller, which at the end of the day is a way that I can do a database lookup and know which device I'm looking at. Okay, so maybe I can zoom in a little more. So let's connect up first board. This should go pretty quick if everything works. Okay, so we're powered up. Bring up the programmer utility. It's annoyingly buggy, which kind of causes problems time to time, but it gets the job done. Okay, so go over here, and we'll hope that its automatic mode works, where it'll just, every time I power up and down a board, it'll try to load firmware. And let's give it a start. Okay. Firmware loaded successfully. We'll copy the serial number. As you might see over here, I've recently added code to this checkout firmware to actually test the sensor's interrupt line. I wasn't in the early ones. It's not required, but the real firmware uses it quite extensively. It's also something that's not likely to be broken, but still good to check anyways. So, okay. Next thing we need to do is press the buttons in sequence. 1, 2, 3, 4. Sensor read is okay. Voltage, the core is okay. 5. And then we also can look at our bench meter. And if the current is a bit low, it means one of the LEDs might not be working. And it's showing the current at about 16.8 milliamps, which makes me think one of these LEDs isn't working. And yep, D3 is not working. So we're going to fail that one, rework, LED, D3 not working. You can pretty easily tell if there's an LED problem just from the current draw. If it's between 18.5 and 21, everything's probably good. If it's below 18, one of the LEDs is probably not lit up. The LEDs aren't running at full power because I don't want to blind myself while doing testing, but they're still reasonably bright. Full power, each of those LEDs is drawing 20 milliamps, which for a density measurement I want, but on the bench, when I'm staring at the board, I do not. Okay. Serial number, sensor working. Current draw says 19.7.5. I'm going to guess the LEDs are all working. Let's see, 1, 2, 4, 5. Yep, all LEDs working. Pass. Okay. Current looks good on this one. Yep, that's a pass. Yeah, okay. Wonder what a good time for streaming would be. I know not many people are on at this hour. It's the most convenient time for me, though. And I could do it earlier in the day. I don't know how good, like, how well that would work by comparison. This might be another LED issue. Yep, LED broken, D1. It's amazing how many solder problems I've had with those. We are, okay, now I feel less bad about fixing FB1 because I have to fix something else on the board anyways. So, yeah. Again, these are all very easy fixes to make, but it reinforces the fact that I have to extensively test every single board before I can put it in a real device. Because once the device is all screwed together and sealed up, it's much more difficult to take it apart to fix something. I'm going to guess that's another LED issue based on the what the power supply is telling me. Okay, this is weird. Yeah, this has happened on a few boards. The detect switch in the back, which is the switch that's used to determine whether the densitometer lid is open or closed, so it knows when to turn the light on. On a few devices, it requires excessive travel before it triggers. And this is one of those. I have to pretty much press it in all the way and then some before it triggers, which is not a good thing. This one and, yeah, LED D1 is broken. So this one, not working. SOU5 requires too much travel. Yeah, so any of these with that detect switch issue, I'm flagging to revisit later. I'm going to have a test rig to find out if it's a problem or not, and if it is, I might have to replace those switches. I'm not blaming PCB assembly for that. I'm blaming manufacturing issues with the switches themselves. My only concern is I'm not sure how easy it's going to actually be to desolder those switches. So otherwise, this one, yeah. Okay, so got one more to put test firmware on. Then we'll fix those LEDs, make sure they're working, and then do the final USB test, and that'll probably be it for today. Now, I was so worried about things being soldered incorrectly or issues with the sensor. Nothing ever wrong with those. Okay, that one. Oh, another LED's down. D1. Yeah, that's drawing 18.7, so can't always pick it up by current. D1. So yeah, I do a visual inspection. The panel's almost perfect. Power it up. 4 of the boards have LED problems. Pro tip: if your design has been previously assembled with a 4mm stencil, don't use a 3mm stencil. Long story. But at least my assembler is planning to make good and is probably going to refund for anything I have to fix. And these fixes are still so much easier than building all these boards myself. So, you know, it's still a win in the end, even if it's annoying in the short term. So, okay. Now we're going to do some rework. So let's switch over. We've done this so many times, it shouldn't be very hard. Okay, so we'll start with 162, which is LED D3. For this, I usually just plug it in and toggle the power so we can be sure we're doing the right thing. So D3. Yeah. Now, this is one of those things that you can see with the microscope when you know what to look for. But when you don't know what to look for, you can't see it so well. So let's see if I can make something visible here. So yeah, let me switch over to the microscope camera. You put a block underneath the board to prop it up. That makes it sometimes easier to see. Wonder if this is even going to be obvious on the microscope camera. The exposure's way too high. Yeah, that's a little better. Yeah, it's not so easy to see this kind of issue. And what's actually interesting about it is I can make the contact with a multimeter probe and light it up, as you're going to see right now. So right here, if I just put my probe there, see, it just lights right up. It's just that pad is just not making good connection. So, yeah. Turn the light off. Squirt a little flux in there. Wonder if I can actually do this one live on camera. That'd be kind of neat. I mean, it's certainly easier. The focus point between the microscope and this camera, since I got the new sort of reducing lens, is not as bad as it used to be. We'll see if I can do this live. No promises. What looks like a little hair or something next to the LED, that's just glare. Yeah, the rest of them I'll probably switch back to stereo on the microscope. There we go. Okay. And keep going. If I'm going to be doing anything on the microscope beyond just the casual look-see, probably need to worry about this exposure issue. And now, voila, it's working. Okay, so that one's fixed. D3, we'll move that to pass. Okay, now we have 165, which should be D1. There's D1. probably need to figure out how to change the timeout settings on this soldering iron. It wants to like cool down every time I put the handle back. Okay. Yep. Okay. The next one is D1. Yep. Same issue again. That the joint on one side isn't working. Just glad this particular problem is extremely easy to fix. Okay, and I believe this is the one where that switch at the back was acting a little dodgy. This one right here was requiring me to push it in a little bit too far to trigger. The way this switch is designed, I seriously doubt that there's a soldering issue with it. It's entirely possible some internal part got melted during reflow. But I'm not going to worry about that right now. I'm just going to sort of put this off to the side and figure it out later. So the last one is D1 on 167. And how much you want to bet? It's the exact same joint. Yep, and it is. Okay. Just swab that one. Cook. Very fast drying cook, and I'm spraying it out of the way. Okay. And it's working. Yay. Okay. We've completed a rework on all the LEDs. Let's turn off the microscope camera. Okay. We have one more test to do before this panel is done, and we'll probably call it a day after that. I've done many other panels today. This is just sort of the last one to get through. So the last test that we have is called the USB test, and that one's easiest to do if I sort of show you the desktop of the computer. Did I close that program? Yeah. Okay, so we have a few things at hand here. We have this program called USB Tree View, which shows all the USB devices plugged into the computer. And we have this terminal window that's on the serial port this device is most likely to show up at once it's online with the test firmware. So what I'm going to do is I'm just going to go through each board. I'm going to hold down a button that should bring it up in bootloader mode. And in bootloader mode, what I'm going to do is I'm just going to make sure that it shows up here as an STM32 bootloader. And then I'm going to unplug it and plug it back in, and it should show up as a serial device, and I should be able to make something go there. So this should be really quick because I'm sort of eager to call it a day. Okay, so we plug that one in. Yep, bootloader. Plug it in again. Serial device. Ta-da! Okay. Yeah, see, this is the one where that switch was acting dodgy. I pushed it in all the way. It registers, but don't know if I really want to sell a device like that. I'm probably going to do is single out those devices and then go ahead and try to replace the switches, but leave them for later. So the USB ones all pass. I'm going to mark all these boards now as pass. The ones that are labeled revisit I'll sort of filter out specifically later. Okay, so probably about time to call it a day. I'm not sure how many people were watching that, but we went through another panel inspection, testing, fixing. I've been doing that a good chunk of last week and a good chunk of this week. I still have more to go, but I'm definitely over the hump. And yeah, I might do the occasional live stream from here on out if anyone wants me to. But yeah, so project's chugging along. And until later, bye.